This is our video tutorial for Unit R Lesson 2, which is about algebra tiles. The first question in our consolidation asks us to draw a picture of each of the algebra tiles and state what they represent. We know that the small little squares represent the number 1. So when we have a red small square, we know that's going to be positive 1, and when we have a blue one, it's going to be negative 1. In your booklets, you might find that there's some shading. When you shade in a tile, it would represent a positive, and when you leave a tile unshaded, it would be a negative. Then we have the X tiles. The X tiles are the ones that look like rectangles. They're of an unknown length. Again, a positive would be represented with red, so a red rectangle would be positive X, and a blue rectangle would be negative X. The bigger squares represent x squared. They are x tall by x wide, so x times x gives us x squared. The red ones are positive x squareds, and the blue ones are negative x squareds. And then finally, we'll have three-dimensional algebra tiles. The three-dimensional algebra tiles will be x times x times x, or x cubed. Red ones will be positive x cubed, blue ones will be negative x cubed. This expression contains two big red tiles, which will be x squared tiles. So we'll have positive 2x squared. It's positive because they're red. There are two of them, so we have a 2. And they're big squares, so they will be x squareds. We have 5 of the rectangles, or 5x. It's positive because they're red. And then finally, we'll have 8 number tiles. So we'll have the number 8, and it will be represented by a negative because they are blue. Altogether, this expression represents 2x squared plus 5x minus 8. To draw a set of algebra tiles for this expression, we'll need to begin with a negative 3x squared. We'll use blue to represent the fact that it's negative, and we will have big squares to represent the fact that it's x squared. We'll have 3 that are blue. The second part of the expression has 4x squared, and it's positive, so we're going to need red squares. We'll need 4 of them. Then we'll have 2 rectangles for the x's, and they'll be blue because it's negative. And then finally, we'll have negative 5. We'll need 5 of your number tiles, and we'll need them to be blue. You might notice that the negative 3x squared and the positive 4x squared could be simplified. We could create some 0 pairs, and we would be left with 1x squared. That would be positive. So then the expression could be simplified to be 1x squared minus 2x minus 5. To represent this set of algebra tiles, we'll use 2 blue rectangles for the negative 2x. We'll use 8 red small squares for the positive 8. Then we will use 2 red rectangles for the positive 2x. We'll use 3 blue small squares for the negative 3. And then 1 more red rectangle for the x. Remember that when we just see a variable like x, we know that's a 1x. The fifth question asks us how else we could represent the expression that we just did. We know that some of those x tiles, or the rectangles, could be put together, and some of the number tiles could be put together as well. So if we rearrange everything so that all of the rectangles are beside each other and all of the number tiles are next to each other, we'll be able to simplify things. We'll see that some of the negatives and positives will cancel each other out or make 0 pairs, and we'll be left with just 1x. The same thing will happen with the number tiles. We'll be left with positive 5, since the positive 3 and the negative 3 could create 0 pairs and just leave us with positive 5. So the final expression would be 1x, or just x, plus 5. To represent the expression 4x minus 5, we'll use 4 red rectangles and 5 blue small squares. To draw the picture of the same expression showing how it would be different if we know x is equal to 3, we're going to replace each of the rectangles with 3 small red squares. That's what x equals 3 means, that for every one of the rectangles, x's, it has 3 positives in its place. As we can see, that will leave 12 positive small squares and 5 blue negative small squares. Again, we can look for 0 pairs, and we will see that there are 7 positive small squares left after we cross out the 0 pairs. This means that the expression can be simplified to positive 7.